When you hear the word neon, I bet I know exactly the image that just flashes into your mind,
Oh, absolutely.
right? You picture this like glowing, rain-slicked city street at midnight. You see the buzzing, flickering signs of a casino or, a retro diner, some moody atmospheric nightlife scene.
Yeah, the classic cyberpunk aesthetic.
Exactly.
Right.
Neon is loud. It's intensely visual. It is the absolute glowing heartbeat of the urban aesthetic. But today, our mission is to completely flip that image on its head.
Because the neon you think you know is, well, it's essentially an illusion.
Yeah. Today on the deep dive, we're unpacking a source document simply titled neon.pdf. And the reality it reveals is that neon, which is atomic number 10 on the periodic table, is a completely invisible, odorless ghost of an element.
It really is. It's a gas that absolutely refuses to interact with almost anything else in the entire universe.
It just drifts around completely silent and completely unseen. That is, until you force it to speak by, hitting it with high voltage electricity. So, welcome to the deep dive.
Thanks. It really is a fascinating contradiction, you know? Today's deep dive isn't just about admiring a glowing advertising sign. We are looking at a diamagnetic noble gas with an absolutely incredible journey.
Oh, yeah.
We're going to trace its existence, spanning from the massive, violent furnaces of exploding stars all the way down to the delicate, microscopic precision of modern semiconductor manufacturing right here on Earth.
And to understand why neon is so elusive and, culturally fascinating on Earth, we actually have to look up first.
We do.
We have to look at where it comes from, because it wasn't just sitting around in the primordial soup since the dawn of time. I always used to think, all the elements on the periodic table just kind of popped into existence during the Big Bang. But that's not how this works, right?
No, not at
Yeah.
all. In the very early universe, like moments after the Big Bang, you really only had the simplest elements.
Mostly hydrogen, right?
Mostly hydrogen,
Yeah.
some helium, and maybe tiny traces of lithium. But that was it. If you want anything heavier, like carbon, oxygen, or, our invisible friend neon, you need time. And you need an unimaginable amount of pressure.
Wow.
Neon was forged through a process called stellar nucleosynthesis.
Which means it's literally cooked into existence inside the core of a star.
Exactly.
But how exactly does a star cook a new element?
Well, it's a constant violent battle between gravity and fusion. A star is immensely massive, meaning its gravity is constantly trying to crush it inward.
Right.
So to prevent collapsing, the star's core fuses hydrogen atoms together to make helium. This fusion releases an enormous amount of outward energy, which balances the crush of gravity.
Like pushing back against the weight.
Yeah, exactly. But eventually the star runs out of hydrogen. Gravity starts winning, the core compresses further, and the temperature just skyrockets. Now it's hot enough to fuse helium into carbon.
Like a collapsing building that suddenly finds a new, stronger support beam?
Precisely. That's a great way to put it. But neon requires an even more extreme environment. It is primarily synthesized during the highly advanced stages of a massive star's life. We are talking stars much larger than our sun.
Okay.
Once these massive stars exhaust their helium, they compress again, reaching core temperatures of over 1 billion degrees.
1 billion degrees.
Yeah. And this triggers the carbon and oxygen burning phases. It is in this unimaginably hostile, high-pressure environment that carbon and oxygen atoms are smashed together with such force that they actually fuse to create neon.
Okay, let's unpack this. So neon is basically a cosmic trust fund baby,
I love that.
right? It's born in these incredibly dramatic, chaotic, stellar furnaces, but when it finally gets to Earth, it refuses to do any heavy lifting. It doesn't settle down and get a real job building mountains or oceans. It doesn't bond with silicon. It doesn't bond with oxygen.
That is actually a brilliant way to frame it because it gets right at the mechanics of earthly geology. Elements like iron, silicon, and carbon are the building blocks of our planet because they love to bond.
They like to mingle.
Right. They form stable minerals, they create soils, they form heavy ores that sink down into the crust. Neon does absolutely none of that.
Because it's a gas. But wait, oxygen is a gas, and it's trapped in rocks all over the world.
Exactly. Oxygen is highly reactive, so it gets locked into solid compounds.
Yeah.
Neon is completely unreactive, and it's very light. It's actually lighter than our breathable air, though slightly denser than helium.
Oh, I didn't know that.
Yeah. Because it refuses to chemically anchor itself to heavier solid elements, it just can't be trapped in the Earth's crust. Over billions of years as the Earth formed and went through its chaotic early stages, much of our planet's original neon simply escaped the atmosphere.
It just drifted back out into the vacuum of space.
Basically, yeah. What we are left with today is merely a diffuse, microscopic trace gas. For every million molecules of air you breathe, only about 18 of them are neon.
18 out of a million.
Yeah.
Which brings up a crazy logistical problem.
Hmm.
If it's not in the ground and we can't mine it from a rock, how do we actually get it? The source mentions we have to extract it straight out of the sky using a process called fractional distillation of liquefied air.
Right.
And the mechanics of this are just mind-bending to me. You don't just filter the air, you have to physically change its state of matter.
Oh, it is a massive, incredibly energy-intensive industrial process.
Ah.
To get neon, you first have to take atmospheric air and compress it intensely while simultaneously cooling it down.
Okay.
And you keep cooling it until the air reaches about minus 200 degrees Celsius. At that point, the air we breathe literally condenses into a freezing liquid.
So you have a giant vat of liquid sky.
Basically, yes. And this is where the distillation part comes in. Every element in that liquid air has a slightly different boiling point.
Right.
So you take this incredibly cold liquid and you very, very slowly start to warm it up. As the temperature rises fractionally, different gases boil and turn back into a vapor at different stages.
And neon boils early.
Extremely early. Neon has an incredibly low boiling point of minus 246 degrees Celsius.
Mm-hmm.
So it boils off and separates, while other components, like oxygen, are still trapped as a liquid.
That is staggering. We are fundamentally fighting against the very nature of this gas just to collect a tiny amount of it.
You really are.
It's scarce economically, not because it's hidden in some deep underground vault, but because it is spread so absurdly thin across the entire atmosphere. We are constantly swimming in it. Like, it's brushing up against our skin, entering our lungs every time we take a breath, but it doesn't interact with our bodies or the Earth at all.
And the reason it ignores our biology entirely comes down to its fiercely independent chemical personality.
Okay.
It is entirely driven by its atomic structure, specifically its electron configuration. Neon is atomic number 10, meaning it has 10 protons and 10 electrons. That configuration is written as 1s2, 2s2, 2p6.
Which, I'll be honest, sounds like a very secure Wi-Fi password.
It does, yeah.
But in practical terms, for those of us who haven't taken a chemistry class in a while, what does that string of numbers actually tell us about how neon behaves?
Well, it tells us everything about why it behaves like a ghost. Think of an atom's outer shell of electrons, like a jigsaw puzzle.
Okay.
Most elements in the universe are missing pieces in their outer shell. Because nature loves equilibrium, these atoms are constantly seeking to complete their puzzle. They will share, steal, or give away electrons to or from other atoms to reach a full shell of 8.
Right, they want to be complete.
Exactly. That sharing and stealing is what we call a chemical reaction. It's the basis of all molecular bonds.
So, like, oxygen wants to share pieces with hydrogen, and boom, you get water.
Exactly. But neon comes out of the box with every single puzzle piece perfectly in place. Its outer shell already has those perfect 8 electrons. It is chemically satisfied. It has absolutely zero incentive to gain, lose, or share an electron with any other element in the universe. This makes it a noble gas. It is totally inert. It will not corrode metal. It will not catch fire. It is completely non-toxic.
In the intro, you also called it diamagnetic. Does that have to do with these perfect puzzle pieces too?
Yes, it's a direct result of it. Because every single electron in neon is perfectly paired up in its atomic orbitals, there are no unpaired electrons to interact with magnetic fields.
So it's immune to magnets.
More than immune. If you expose neon to a magnetic field, it doesn't just ignore it. It actually creates a microscopic opposing field that slightly repels the magnet.
That's wild.
Yeah, it's so perfectly self-contained that it physically pushes away outside influence.
It is the ultimate biological ghost. Evolution essentially bypassed neon entirely because neon outright refused to engage in the chemistry required for life.
Right.
It plays zero role in our DNA, our blood, our metabolism, plants, or microbes. If you breathe it in, it just comes right back out, completely unchanged.
Yep, completely untouched.
In fact, breathing pure neon is only dangerous for a purely physical reason. The text notes it physically pushes the oxygen out of your lungs so you suffocate. The neon itself isn't poisoning you, it's just taking up space.
It is a profound level of aloofness. It is entirely useless to geology, entirely useless to biology, and, completely invisible.
But wait, here's where it gets really interesting.
Okay.
Our source document contrasts it with fluorine, calling fluorine a relentless hunter. But if neon is so incredibly aloof and entirely useless to life and geology, How did humanity even notice it? Why didn't it just stay an invisible ghost forever?
What's fascinating here is how we finally spotted it. We discovered it in 1898. Specifically, two chemists named Sir William Ramsay and Morris Travers discovered it.
Oh, right.
And they found it precisely by playing with that liquid air distillation process we talked about earlier. They boiled away the liquid air, captured the tiny bit of leftover gas that refused to turn into a liquid, and wondered what it was.
But you're right, you can't test it with standard chemistry because it doesn't react to standard chemical tests.
Exactly. So how do you prove it's there?
Right.
You shock it. Ramsay and Travers took this invisible, mysterious leftover gas, sealed it inside a glass vacuum tube, and ran a high-voltage electrical current through it.
Hmm.
And the moment they did that, the invisible gas suddenly exploded into a brilliant, blazing crimson-red light. What they discovered is that neon doesn't change itself by bonding with other chemicals.
Yeah.
It reveals itself by glowing.
Man, that is cinematic. It's the quiet loner that stays perfectly silent right up until the exact moment it's pushed into the spotlight by thousands of volts of electricity.
Yeah.
But what is physically happening in that tube? Why does electricity make an invisible gas glow red?
Well, it goes back to those perfect puzzle pieces, the electrons. When you blast neon with a high-voltage current, the pure energy of that electricity hits the atom and violently knocks some of its outer electrons into a higher, wider orbit,
Oh.
a higher energy state.
Oh, they don't want to be there.
Right, it's unstable. Almost instantly, those electrons drop back down into their comfortable original orbit. But energy cannot be destroyed. The extra energy they absorbed from the electricity has to go somewhere when they drop back down. So the atom expels that energy as a photon, a tiny packet of visible light.
And the color of that light depends on the exact distance the electron falls.
Exactly. Every element has a unique structural distance that its electrons fall, which creates a very specific wavelength of light. It's like an elemental fingerprint.
That makes sense.
For neon, that specific atomic drop produces photons that our eyes perceive as a brilliant, piercing red-orange.
And here is a fact from the source that completely blew my mind. Pure neon only glows that famous red-orange color. That's its absolute spectral signature.
Only red-orange, yeah.
So if you are walking down the street and you see a quote-unquote neon sign that is glowing bright blue or green or purple, you aren't actually looking at neon at all.
That's right. You're looking at other noble gases being electrified. For example, argon glows a pale blue when you hit it with electricity. Helium glows a pinkish white. Yeah, if you want green or yellow, you have to coat the inside of the glass tube with specialized fluorescent phosphors or, mix different gases together. But true, pure neon is strictly that intense, warm, electric red-orange.
That electrical spotlight changed human civilization. Because we couldn't interact with neon chemically, we learned to interact with it technologically. And it gave us a completely new visual identity for our cities.
It did. But we really need to expand this conversation beyond just the neon signs in diner windows and casinos.
True.
The 20th century urban aesthetic is famous, but neon's role in modern 21st century industry is arguably far more critical, and it happens entirely behind closed doors.
We're talking about lasers, right?
Yes. Pure neon is a vital component in precision optical technology. For decades, helium neon lasers were the standard for alignment systems, laboratory measurement, and even early barcode scanners.
I remember those.
Right. But critically, in modern manufacturing, neon is absolutely essential for something called excimer laser systems.
Okay, stop right there. Excimer laser is a term that gets thrown around in tech circles.
Yes.
But what actually is it, and why on earth does it need an inert, unreactive gas like neon to work?
Well, an excimer laser, and the word excimer is short for excited dimer.
Okay.
It relies on a bizarre chemical trick. You take two gases that normally hate each other and refuse to bond, like a noble gas and a highly reactive halogen. Under normal conditions, they just ignore each other.
Right.
But if you blast them with a massive electrical pulse, they are forced into a temporary high-energy bond. A fraction of a second later, that unnatural bond breaks apart, and when it breaks, it fires off an incredibly intense, ultra-precise beam of deep ultraviolet light.
That sounds violently unstable. Where does the neon come in?
Because that reaction is so violent and intense, it generates an enormous amount of excess thermal energy, and it's very hard to control. You need a buffer gas.
Oh.
You need a material to flood the chamber that could absorb the shock and distribute the energy, but without accidentally joining the chemical reaction and ruining the laser.
And because neon has its perfect 8 electrons and refuses to react with anything, it's the perfect bouncer for this microscopic club.
Exactly. It stabilizes the environment while remaining completely aloof. And the deep ultraviolet light generated by these neon-buffered excimer lasers is the cornerstone of modern semiconductor lithography.
Lithography is how we make microchips, right? Like carving the tiny pathways onto silicon.
Yes, we are talking about carving microscopic, incredibly complex nanoscale patterns onto silicon wafers. These are the microchips that run every computer, every smartphone, every modern car, and AI server farm on the planet.
Everything, basically.
You cannot carve patterns that tiny with visible light. The wavelengths are just too fat. You need the ultra-thin wavelengths of deep UV light, and you cannot generate that precise UV light without highly purified neon acting as the buffer in the laser.
So what does this all mean? We think of neon as the loud, flashy guy at the party. It's the advertising, the spectacle, the casino strip. But in reality, it's quietly running the VIP room of global precision manufacturing.
If we connect this to the bigger picture, it leads to a very delicate vulnerability in our modern supply chain. Environmentally, neon is quite gentle. It isn't a greenhouse gas, it doesn't pollute water tables, it isn't chemically toxic.
Right.
The real fragility lies in our technological dependency and the sheer mechanics of acquiring it. Because capturing neon from the atmosphere and purifying it to the extreme 99.999% purity required for a semiconductor laser is so monstrously difficult, the global production is highly concentrated.
Because you can't just set up a neon mine anywhere. You need these massive, multi-million-dollar cryogenic distillation facilities.
Precisely. If a few specific facilities around the world stop producing it, whether due to supply chain shocks, economic shifts, or regional instability, the entire high-tech manufacturing sector feels the shockwave.
Wow.
It is a highly specialized dependency. A shortage of neon won't cause the electrical grid to shut down tomorrow, but it can severely bottleneck the global production of the advanced electronics that run our modern infrastructure.
Which brings us to this incredible, strange dichotomy. We have a gas that is essential for cold, hidden precision tech, but it is famous for loud, warm public advertising.
Yeah.
And this creates a very specific emotional resonance for humanity. It is amazing to me how a colorless, tasteless, odorless gas can carry so much emotional weight.
The sensory and emotional profile of neon is entirely unique among the elements.
Well,
Think about its characteristics. It is a chemical loner that only speaks through electrical excitation.
have you ever actually stood under one of those buzzing diner signs on an empty street at night?
Oh, sure.
It's completely captivating. The hum of the transformer, the buzzing glass tube, the way the red-orange light reflects off rain on the pavement.
Right.
It feels cinematic, nocturnal, and honestly a little lonely.
That physical containment you just mentioned, the buzzing glass tube, is a powerful metaphor. Philosophically, neon is often described as the element of attention without intimacy.
Attention without intimacy. Explain that.
Look at how it behaves. It glows brilliantly, it pierces the darkness, it demands to be looked at, yet it remains totally sealed off inside a glass vacuum.
Trapped.
Right. It is chemically and physically distant, refusing to touch the outside world. It perfectly symbolizes modern commercial life. Bright, public, incredibly aesthetic, but completely untouchable.
Think about what stands out to you when you see a neon sign. It's beautiful, but it's completely trapped in a glass tube, right? Humanity used neon to make the darkness legible.
Yes.
Before electrical illumination and neon tubes, night was just, well, dark. Maybe you had a dim gas lamp. But neon turned the night into a theater. It allowed us to paint the darkness, to mark places, sell dreams, and create an entirely new atmosphere that simply did not exist in nature.
It is fascinating to realize that human civilization would absolutely survive without it. It's what you might call a Tier 3 dependency. If neon vanished from the atmosphere tomorrow, we wouldn't starve. We wouldn't suddenly be unable to breathe. But we would lose an entire visual language. We would lose the aesthetic of the cyberpunk city, the glowing street, the entire mood of 20th century urban nightlife.
That's so true.
Neon doesn't build physical bodies like carbon does. It doesn't sustain breath like oxygen does. It simply reveals, it announces.
The story of neon is the story of silent matter becoming unforgettable, but only when it is touched by immense energy. It's a great reminder that not every element matters because of what it physically builds in the dirt.
Right.
Some matter because of the perception they enable. Neon transformed our modern cities by giving them a nighttime soul, written entirely in artificial light.
And that artificial light was our first real step into curating the night.
It really is a profound way to look at something we usually just walk right past on our way to get a late-night coffee. So let's recap this incredible journey we just took into neon.pdf.
It's been quite the ride.
Right. We started out in the unimaginable heat and pressure of nuclear fusion inside massive ancient stars where carbon and oxygen were smashed together. We followed this invisible ghost as it was blasted out by supernovae, only to end up on Earth refusing to bond with anything, drifting through our atmosphere as a trace gas.
We explored its fiercely independent atomic structure, those perfectly paired electrons that make it ignore our biology, repel magnetic fields, and resist every attempt at standard chemistry.
Requiring us to literally freeze the sky just to capture it.
Exactly.
And we saw how that same untouchable nature made it the perfect, stable buffer gas for the excimer lasers carving our microchips, and the perfect candidates for electrical energy, transforming it from an invisible chemical loner into the glowing red-orange heartbeat of the modern city.
Yeah.
So, to you listening, the next time you're walking down the street at night and you look up to see a glowing red-orange open sign buzzing in a window, realize you aren't just looking at cheap advertising.
Not at all.
You are looking at a chemically silent, diamagnetic, cosmic ghost, a stellar relic trapped inside a glass tube that only speaks when we electrify it.
And that raises an important final question to leave you with today. We'd established that neon represents humanity's desire to make the darkness legible. It gave the 20th century city its nighttime soul, a soul characterized by visibility, commercial spectacle, and a certain electric, untouchable loneliness.
Yeah.
But technology evolves. If our 20th century soul was written in the warm red-orange glow of an isolated gas sealed inside a vacuum tube, what invisible material will we eventually electrify to define the aesthetic and the loneliness of the 21st century?